So what we're going to look at here is the electronic configuration of the first 20 elements. That's a posh way of saying the arrangement of the electrons in the first 20 elements. If you remember, atoms of elements are made of 3 subatomic particles: protons, neutrons, and electrons. Now, protons and neutrons live in the nucleus, whereas the electrons, they live in shells around the nucleus. Now, those shells can hold different numbers of electrons. So the first shell of electrons will hold a maximum of 2 electrons, 2. The second shell will hold 8 electrons, a maximum of 8. The third shell will hold 8 electrons as well. The fourth shell will actually hold 18 electrons, but we only need to do the first 20 elements. So if we think about it, with 2 on the first shell, 8 on the second, that's 10. 8 on the third shell, that's 18 in total. We're only going to have to worry about 2 electrons going on the fourth shell, but we'll say the fourth shell holds 18 electrons, or if you want to just remember it as the rest, that's fine by me for GCSE. So what we've got here is a periodic table of the first 20 elements. If you look at the big periodic table, hopefully you can see why it looks a bit different. The periodic table reads like a book, so element number 1 is at the top here, hydrogen. And we've got helium over here, so this one here will be hydrogen, and that will be helium. Then we've got lithium and beryllium as elements 3 and 4. Now, we've got this big group of transition elements in the middle. Now, none of these are the first 20. So I, on this page, have squashed that gap. Transition metals would go there. And then we've got boron, carbon, nitrogen, oxygen, fluorine, and neon, finishing off that group, that period there. And that's those ones there. So hopefully you can see how that works. So with this sheet, the first thing I want you to do is write the element symbols and atomic numbers, and we're going to write them quite small down the bottom. So that was hydrogen and 1. I've written that really small, if you can see that in the video, but hopefully you can. Helium and 2 there. Lithium is 3 over here. Beryllium element number 4. Boron 5. Carbon 6. Nitrogen 7. Oxygen 8. Fluorine 9 and neon 10. You get the idea, and you can finish all those off for the first 20. I'm not going to draw all of them in this video; it will be too long. Okay, let's put a couple of others down just to for completeness sake. I'll do sodium 11. Let's do chlorine 17, and let's do calcium 20. I'm not going to do all of them. We don't have time in this video. You can fill them in. So what we do after we've done that is I'd like you to draw a diagram showing the electronic configuration, draw a diagram showing the arrangement of the electrons. Now the rule is we fill from the inside out. So with hydrogen, let's have a dot for the nucleus. Nucleus contains all the protons and all the neutrons. Okay, the protons give the atom its identity. But we're just going to show that as a dot because the nucleus does not get involved in chemical reactions. The electrons, however, do, so we are much more interested in those. Hydrogen has got an atomic number of 1. We wrote that down quite small down there. If you can't see it, the atomic number is 1. So we're going to draw one shell, or we could call it an energy level or an orbital. I'll call it a shell. And we're going to put 1 cross on that to show it's got 1 electron. And we can show the electronic configurations, write the electronic configuration just by going 1 dot, showing it has 1 electron on the first shell. Likewise, helium, dot for the nucleus, 1 shell, but this time it's got an atomic number of 2, so we're going to have 2 electrons. Okay, and we're going to write that as the electronic configuration as 2 dot. And we carry on now. Lithium over here, much the same way. 3 protons, so therefore 3 electrons, dot for the nucleus, 2 electrons on the first shell, and 1 electron on the second shell, because the first shell is now full, you see. The first shell holds 2 electrons. This has got 3 electrons, so 2 go on the first shell, 1 on the second shell. Beryllium, 4 electrons, because it's got 4 protons. 2 electrons on the first shell, so we need a second shell because the first shell is now full. And 2 electrons on the second shell. And we're going to write these electronic configurations now. Lithium can be 2 dot, because we've now got a new shell, 1. This one here, 2 dot 2. Let's carry on to oxygen, and as I say, I'm not going to do all of them. Dot for the nucleus. First shell. Now oxygen has 8 protons, so it has 8 electrons. 2 electrons on the first shell. That means there's 6 more to think about. Now the second shell can hold 8, so we're going to go 1, 2, 3, 4, 5, 6 on the second shell. And with those 2 on the first shell makes 8. So it's going to be 2.6 is the electronic configuration, and that totals the 8. Let's do neon now to finish this period. It's got an atomic number of 10, so 2 on the first shell, and this time 10 in total, so 8 on the second shell, and that will fill this shell. 1, 2, 3, 4, 5, 6, 7, 8. You'll notice I pair the electrons up on these shells. It's technically correct to do that. It doesn't matter if you space them out for GCSE, but it's technically correct to pair them up. There is only 4 spots on this shell the electrons can go. But it's a more practical reason as well. It's just dead easy to count. I've got 8, 2, 4, 6, 8. You can just see it without necessarily having to count. If you space them out, it's actually quite easy to draw 9 without realising it. Right, let's do sodium down here now. Sodium symbol Na. It's got an atomic number of 11. So 11 electrons. 2 electrons on the first shell. Okay, 8 on the second shell makes 10. You'll notice I'm pairing them up again. And that leaves 1 electron more. Now this shell is now full, so we now need a third shell. We need a third shell. And that's going to have the 11th electron on. Let's do chlorine, 17. 2 electrons on the first shell, 1, 2. 8 electrons on the second shell. 2 and 8 makes 10, which means that this third shell, which we now have to have, must have 7 electrons on it. 2, 4, 6, 7. Writing the electronic configurations of these now. 2.8.7. 2 on the first shell, 8 on the second, 7 on the third. This one down here, writing the electronic configuration. 2 on the first shell, dot 8.1. 2, 8, 1. Let's do calcium now. Let's finish this one off. 20. This is a 20th element, so this is the biggest one we have to draw. So we need 2 electrons on the first shell. 8 electrons on the second shell makes 10. Third shell. We've got 20 in total. 2 on the first, 8 on the second makes 10. 8 on the third, that's going to make 18. So the third shell is also full. Because the third shell is full, the third shell only holds 8. We now need a fourth shell. And that's going to have 2 electrons on it to make the 20. 1, 2. So writing the electronic configuration, this one, 2, 8, 8, 2. Right, let's now just label the groups and periods of this periodic table, because there's some trends and patterns. The periodic table is full of trends and patterns. And one of the reasons to do this is I want you to see the trends and patterns of the electronic configuration in the periodic table. To do that, we need to label the groups and periods. Right, groups go down. So this is group 1 over here. Okay, so let's label that group 1. This is group 2 next to it. Group 2. Groups go down. Group 3 here. I haven't really got space to do that because I've written all over it. That's group 3, that one. This one here is group 4, down there. This is group 5, down there. Group 6, group 7. Now remember, this one's called group 0, I often say, because they react with nothing. Okay, periods now. Periods are the rows. Don't ever forget period 1. People forget period 1 because it only has 2 elements in it, but it does exist. Period 1. There it is there. Rows go across. Period 2 is this second one. Period 3 is this third one. And period 4 is this fourth one. Now, so this question here. What is the pattern between the electronic configuration and the group number? Okay, well, group 1, look at the elements in here. I shall just write the electronic configuration of this one. Okay. What do they all have in common? 2, 1, 2, 8, 1, 2, 8, 8, 1. What they all have in common is they all have 1 electron on their outer shell, and they're in group 1. Look at group 2, 2, 2, 2, 8, 8, 2, and this one here would be 2, 8, 2. They all have 2 electrons on their outer shell. 2, 2, 2. Group 3 here, if I'm going to write the electronic configuration of this, it's going to be 2, 3, and then 2, 8, 3. Okay, they all have 3 electrons in their outer shell. So the group number tells us the number of electrons in the outer shell. That's the trend. And that's true of all groups. The group number tells us the number of electrons in the outer shell. So that's quite powerful. That's true of every group, apart from the noble gases. What we'll say there, with the noble gas group, the outer shell is always full. So with the noble gases, with group 0, the noble gases, the outer shell is always full. Okay, so the group number, this one here, 6 electrons in the outer shell. These ones here, 5 electrons in the outer shell. Group number tells us number of electrons in the outer shell. Next trend, periods. Period 1, what do we notice about all the elements in period 1? Well, they've got 1 shell. Period 2, what do we notice about all these elements? They've all got 2 shells. Period 3, what do we notice about those? 1, 2, 3 shells. 1, 2, 3 shells. So the period number tells us the number of shells. Okay, so now we know that, we don't actually need an atomic number to draw the electronic configuration if we know where the element is in the period table. Let's take this element here. I've left this box completely blank. Let's see if we can just use the period number and the group number to draw the electronic configuration accurately. So it's period 3. Okay, period 3 is in the 3rd row. Period 1, period 2, period 3, it's in the 3rd row, so it must have 3 shells because the period number tells us the number of shells. Now we fill from the inside out. So the first shell must be full and the second shell must be full if it has 3 shells. There's no other way of doing it. So we can just fill those with electrons straight away. Now it has 3 shells. So that's what the period number tells us. The first 2 shells are full because it has 3 shells. So the electronic configuration is going to be 2, 8. Now it's in group number 4. So the outer shell must have 4 electrons on it. 2, 8, 4, because the group number tells us the number of electrons in the outer shell. And this element here is silicon. If we look at the periodic table, it has an atomic number of 14. So 2 on the first, 8 on the second makes 10, 4 on the third makes 14. So we don't actually need the atomic numbers. And that is the periodic table showing the electronic configuration of the first 20 elements. And hopefully you can see the trends and patterns in the periodic table and the arrangement of the electrons.